This is Computer Programming 1 from the University of Washington. I'm Martin Dickey. Today's topic is style, and that's why I'm treating everybody to the most beautiful tie I could find. I have to let you in on a secret, though. It's not mine. I don't own anything nearly this stylish, but fortunately my colleague Richard Anderson apparently has a closet full of stylish ties, and he was kind enough to lend this one to me. Well, to be truthful, we're not going to talk about necktie style today, but about program style. We've seen that there are many aspects to doing design and programming. Getting the syntax right is one thing, and to beginning programmers, sometimes that seems the hardest part. It really isn't. Eventually, you learn to master the semicolons and the curly braces, and you find that the hard part is getting the logic right. Sometimes that's hard, but it's absolutely essential. A program that has correct syntax but doesn't operate correctly is not very useful. It's also important to program with good style. We're going to talk today about what this means and why it matters. A program is a kind of a document. It's more than something read by the computer. Human beings also look at it, including that most important human being, yourself. You have to write the program, you have to be able to come back to it and look at it and understand it and fix it and explain it. The whole document is read by people, even though only part of it may be processed by the computer. Donald Knuth refers to literate programming as the practice of writing programs with this in mind, that they are documents meant to be read by human beings. So the word style is not a technical topic, but it's kind of a catch-all term for this approach to programming. It includes some things that are fairly low level, such as comments, spacing, indentation, and names, and other things that are a little harder to quantify and also to teach and to learn, such as being clear and straightforward, having the code well organized and of high quality. Now, as we go through this course, we will suggest and sometimes require that the programs you write follow certain guidelines. Occasionally students will object to this. They feel that their creativity or self-expression is compromised if they have to follow certain rules. But it's really not unreasonable, and in fact our guidelines are relatively loose compared to those of many employers or work groups within large companies. Typically, companies will have quite specific and strict guidelines that employees are expected to follow as a matter of course. The main reason behind this is to ensure that everybody on the large teams which work on programs these days understands the rules that are being followed and can quickly, easily, and reliably understand one another's code. Comments are a very important part of this process. And comments are exactly things which human beings don't read and which the compiler ignores. At the beginning of each program, we recommend that you put a large block of comments of identification, including your name, the overall purpose of the program, and perhaps some summary information about when, where it was developed, and other general information applying to the whole program. In addition, there will be major sections of the program, perhaps functions, where a typical block should also be introduced. For example, in a function header, you would want to describe what the parameters are, what their meanings were, and the assumptions that the function was making in order to operate correctly. Then occasionally, here and there, elsewhere in the program, on variables and particular statements, there might be additional comments. Now, this business of identifying yourself is quite helpful, as other people reading the program may want to go back and look at it. And perhaps it would also give you a little bit of feeling of ownership to know that your name is associated with the code you wrote. It's sort of like wearing a designer tie like this one. I can look down and see that there's actually a signature on it. It says Alessandro, I don't know who he is, but he's Italian. I'm sure that means good style. So think of your code as designer code that you want to be able to sign for the rest of the world to know about. Let's say a little bit more about these comments. The heading comment at the beginning of the file should summarize information of general interest that anyone needing to use that file would find helpful. The function heading comments ought to describe what the function does. They don't need to repeat the details of the statements. Instead, there should be enough information that a person could read only the comments of the function in order to figure out how to use it. That is, what parameters to call and what to expect back from it. We recommended in an earlier lecture that you declare variables as you discover you need them, rather than trying to think ahead of time what variables you might need and putting them at the top of the program. As you develop the algorithm, the loops, the finals, the parts of the program that carry out your intentions, you'll discover you need variables. That's the time that you should go back and declare them, and that's the time at which you should write a comment, when the meaning and purpose of that variable is still fresh in your mind. Believe me, it will help you in reworking and revising your program as much as anyone else who has to go back and read it. Finally, you might put comments on individual statements or small groups of statements. It isn't necessary to put a statement on each line, and as with function statements, you shouldn't simply repeat the code. So if the statement is sheep gets sheep plus 1, it's really not only unnecessary, but it's really annoying to see a comment like subtract 1 from sheep. More interesting would be a comment like the one you see next, which explains why sheep gets sheep minus 1. Spaces are a very simple and yet very effective way of making your program easier to read. Some programmers like to line up assignment statements, as you see here. Many programmers also like to leave space around operators instead of closing everything together. Parentheses can help too, as we discussed when we talked about expressions. Not only are they good style, but they ensure that the sub-expressions get evaluated in the order intended, rather than relying on the default precedence and associativity rules that the compiler will interpret. Finally, many parts of the program have natural opportunities for indentation. The statements following the conditions in an if or a while. Often when you start a compound statement, it's a natural opportunity to indent and then to consistently indent as long as you are in that compound statement. Notice that I'm being a little bit careful here. Instead of saying you must align things, you must leave space around operators. These are often matters of taste, and these are exactly things that might be left to the style guidelines of particular instructors and particular work groups or particular employers. As a programmer, you should be flexible enough that you can adapt your personal style to work within the requirements of your employers and others who will read your programs. Identifiers are another tool we can use to help our programs be more understandable. As we know, identifiers name things like variables, functions, and we know the rules say we can have letters, digits, and underscores. We can't begin with a digit and so forth. We can't use reserved words like double and return. We can't make them into identifiers. Now in C, unlike some languages, identifiers are case sensitive. So you see 4 different versions of a word spelled VAR. That happens to be a reserved word in some languages, but not in C. And all 4 of those would be considered as different variables in C because of the case sensitivity of the language. That does not mean it's good style. In fact, I would consider a program that contained all 4 of those spellings of VAR as a very poor style choice. One thing you could do by the rules for identifiers is write identifiers which are all uppercase. That's perfectly allowed. However, by convention, that is, as a matter of style, most programmers use all capital names only for pound-defined symbols, and they use lowercase or combinations of lower and uppercase for other types of identifiers. The identifiers help tremendously in understanding the very local parts of the program, the statements, because if they're chosen carefully, they can suggest a lot about what the problem is and what the programmer intended. Choosing variable names well can be a challenge, especially if there are a lot of variables. An earlier version of Microsoft Excel was said to have 65,000 different variables. Imagine the challenge in choosing that many names. Actually, at Microsoft, there are some quite elaborate rules for choosing variable names, much more elaborate than we would require in a course like this. Choosing the length of the identifier is another factor. If you make it very short, like M, it's legal C, but it's hard for a reader to guess at the intention. And it'll be hard for you to remember what the intention was if you come back to the program several weeks after you've written it. Believe me, that's happened to me for many years. You might use an abbreviation like MPH, and if it's a standard concept, that might be fine. If it's not so standard, you might want to spell it out, like miles per hour. Now, you could go overboard with this. Perhaps the real meaning of this variable is that it's the average miles per hour that the red car went. You could make a variable of that length, but not only would it be really annoying to have to type it, I think it would be annoying to readers and take up so much space that it would interfere with some other aspect of style, such as indentation. Finally, avoid similar names. The example here looks like it's a case of just capitalization, but if you look very carefully, you'll see one of those actually has an MQH in it. That's perfectly legal. All of those are separate variable names, so it'll compile. It might even work right, but it's going to be very hard on the reader. Some suggestions for names. Things that correspond to objects in the world or to values are often best named with nouns or things like noun. Car, for example. Whereas functions that do operations, simply do some procedural operations, are better described with a verb or a verb phrase, like read payroll records for the second case, as opposed to payroll record for the first case, a noun corresponding to that object, a payroll record. Here are a few more examples. You can pick through these at your leisure to see why they may be good or bad, and perhaps you'll have legitimate disagreements, which is fine as long as you can articulate them and as long as you're willing to make the required compromises that your organization may deem appropriate. Now, in some cases, it's flat out illegal. You can't have a variable called 10 times length, even if that might be the perfect way to name it logically, simply because C doesn't allow you to start with a digit. Likewise, you can't have spaces in the middle of your variables, even though it might be very nice if you could, like file names now in many operating systems may have spaces. People find that very useful. Finally, you'll see cases such as we've already discussed of things that are legal from the C point of view, but they're just bad style. They're short, they're cryptic, or they're long and they're cryptic, or they're confusing among themselves or confusing among concepts that look similar. Clarity is another desirable for a program, and it's one that's a little bit harder to quantify. In general, you should do obvious things in an obvious way. The first statement there might look bizarre. It's actually legal C syntax. What it means is exactly equivalent to the following two statements, consisting of two assignment statements. Now, the second set of two statements would raise absolutely no question in any reader's mind. The reader would know exactly what was intended and what result was achieved. But the first one is probably going to require a visit to the C reference manual to figure out what weird thing is going on here. If that ever happens to your reader, it means you have failed in making the program clear. You're writing not to impress your reader, but to communicate with them. We've talked before about the value of using symbolic constants, which in C can be expressed with pound defines. Just a review of these. We put these near the top of the program. We use the special phrase pound define, then a name, and then with no equal sign, some spaces and the value, and there's no semicolon at the end. The style point here is that this helps our program by providing symbolic names that might make sense as opposed to magic numbers. Also, as a matter of style, most programmers will use all uppercase letters. This alerts the reader that it's not a variable that's being used, but a pound-defined symbol. In addition to being more readable, using these symbols helps you to centralize values that may change in later versions of a program. All of those values are found near the top of the program in the one centrally located pound-defined area and can be quickly located and changed. This compares with having to search through a large program to find where all the constants might be used, a very error-prone activity. You put all these recommendations together, you get a big cumulative effect. Here I've written a program and I've used the minimal amount of spacing. I haven't used any indentation. I've used extremely cryptic, if not misleading, variable names. Is there an error in this program? Well, you know, the way it's written, it's going to take a lot of hard looking and frustrating looking to answer the question. Now, if there was an error in a well-formatted, stylistically good program, it's still an error. But the chances that you'll be able to spot it and quickly change it are much greater if the program is easy for you to read and easy for everybody else to read. So let's think about that as a general approach for style, that clarity is our main concern. Even without a formal or an elaborate style guide, all of these are perfectly reasonable recommendations to follow in all your programming, even things you're doing just for yourself and that you don't expect to show to anybody. Use lots of comments, but don't go overboard to the extent of cluttering your program. Use white space and parentheses. They're free. Use indentation to show how things are related. Choose descriptive names. Use constants that are named by pound defines. Avoid being terse, tricky. Avoid trying to place speed above correctness and simplicity. In later lectures, I'm going to give you some very dramatic examples of the right way to look at efficiency. And as we'll see, it's not a matter of trickiness, but a matter of higher level thinking after all. Please join me as the course continues.